The practice, I can't stress that enough. You don't need me to tell you that you should be doing it, but I know many of you probably don't do it regularly. I will say this also next year, if you are taking, it doesn't matter if you're taking Trig Pre-Calc or AP Stats or any other class, not just math. If you think about it this way, it is unrealistic to, guys, I need your attention. I'd say it's not realistic to think that you can just show up to class every day and not think about class outside of class and then still feel confident on what's going on the next day. And it only gets more difficult as you get into higher level math classes. So especially, I'm stressing that today. I didn't see very many of you correcting Friday's assignment. Today we're building off of that. So today is also a very special case. And if you don't practice how to determine how many types of solutions you could have or how many solutions you could have, that's when you get to the review and you're so stressed out because you're trying to learn an entire chapter in 2 days. That's not realistic. Or you need to own up to it and say, I should have expected this because I didn't do the practice ahead of time. If you're keeping up with everything, then you should be okay. So the special case for today with law of sines. Law of sines hasn't changed since Friday, but this is the SSA case where you are given 2 sides of a triangle and an angle opposite one of those sides. And the case that is called the ambiguous case is when there's actually 2 possible answers. There's 2 possible triangles that could be created from the 2 sides and the angle that you're given. So what I want you to realize, I'm just going to grab my highlighter here, when you are solving a triangle and you are given 2 sides and an angle opposite one of those sides, it is possible that no triangle could possibly be created, so you have no solution. It is possible 1 triangle exactly could be created. I need it quiet, please. This is also why so many students are lost, because when I speak, you're just not paying attention, so you're just watching what I'm doing. It makes no sense if you don't understand it. I'm not just talking to myself. I already know this. Also, it's rude. It's possible 1 exact triangle would be created and you would find that triangle or solve that triangle just like we did Friday. It's possible 2 triangles are possible. And that's the ambiguous cases when there would be 2. So this chart is how you determine how many solutions you are going to have. And I'm going to explain steps as we go through the 3 examples, how to work through these. First, determine how many solutions you would have to begin with, and then go ahead and find them. So when you're reading these, and I talked about this Friday as well, all of these are in terms of some sides given that are A and B, and then some angle given, that's the measure of angle A. But not every example. If you even look at example 1, it's triangle RST. There's no A's or B's in it. So you need to be able to relate the triangle you have to what this chart is trying to help you determine. What I want you to realize from this information is whatever angle you are given, when you're looking at these formulas, the angle you're given is the angle A that's being referenced. So if you just want to make a note, angle A, if it's not A in your example, it's the given angle. And then the little a would be the side that is opposite the angle given. And then side B would be whatever other side you are given. So we're going to relate that when we look at triangle RST, we have to relate RS and T to the A and the B that they're talking about in this chart. So angle A is the angle you're given in the problem. Side A is the side that's opposite the angle you're given. Side B is the other side. So first of all, what you want to do in these problems is you look at your angle A and you determine, is angle A, or the angle I'm given, is it acute? So is it less than 90 degrees? Or is it a right angle or obtuse, so 90 or greater? So I'm going to look over at this side first because this is the easier side to look at. If your angle is a right angle or it's obtuse, Then you have to compare the two sides that you're given. If the side that is opposite the given angle is less than or equal to the other side, there is no possible triangle that could be created from that information. And this is kind of a drawing as to why. So if this angle is right or greater than 90 degrees, and then the side opposite is shorter than this side, that side is never going to reach that third side. No triangle is possible. So your answer would just be no solution. You're done. Move on to the next problem. If the side that's opposite your given angle is greater than the other side you're given, then there's exactly one triangle that could be created. This gives a picture of that. And then you would solve that triangle the same way we were doing on Friday using law of sines. Okay, so if the angle you're given is right or obtuse, it's possible that you don't have a triangle or that you have exactly one. If angle A is an acute angle, this is where it starts to get more complicated. I am going to write down here, if your given angle is acute, I'm going to put here, then you want to compare A to B, just like you would have done here. So if, and it's not written in here, if side A, so the side that's opposite your angle, is smaller than the other side, that would actually be for all of these cases. So for the first three that are listed, not this last one, for all of these, it is implied that your opposite side A is less than the other side that you're given. So if that's true, if the side opposite your angle is smaller than the other side and your angle is acute, then what you need to do is find the height of the triangle H. So I'm going to put find H if A is less than B. And I'm actually going to skip down. If you look below here, there's a formula or an easy way that you can find H every time. So if you look at this triangle here, because they have it drawn in for all of these. They have that height drawn in. And remember, we did this on Friday. We were coming up with the area formula in terms of sine. But when you create that right triangle, notice sine of angle A would be opposite over hypotenuse. So sine of angle A is H over B. And they give that formula right here. And since sine of A is H over B, this is the way you can easily find H every time. So you can find the height H by taking your side B, the side that's not opposite your angle, and multiplying by the sine of the angle that you're given. So find H using that formula if you need to. And then notice all of these have a comparison between side A, so the side opposite the angle, and the height. So if your side A is less than the height, and this gives a diagram, there's no triangle possible. If side A is equal to the height, so they're the same side, there's one triangle possible. It's a right triangle. And this is the ambiguous case. If how this is written, this means A is less than B, and A is actually greater than the height. So if A is greater than the height but still smaller than that side B, there are two possible triangles. And I'm going to, well, the diagram kind of shows them. This is one. And in this triangle, this angle over here, that's opposite side B, that would be angle B. So there's one solution if angle B is an acute angle. The other triangle is if this side is kind of rotated over here, so you get this more funky looking triangle that's smaller there. And therefore your angle B would be right here. and that angle B would be an obtuse angle. Okay, so that's just trying to show you a visual of how possible or how two different triangles could be created from what you're given, and you would have to find both in that case. You'd have to solve for both triangles. Then if angle A is acute, but when you compare A to B, that opposite side is greater than or equal to the other side you're given, then there's exactly one solution, and you'd solve that like normal. So I have 3 examples to go through with you. We're going to be referring to this chart. In order to really fully understand it, you just need to practice with it, at least practice determining how many triangles you possibly have. So in these examples, as it says, you're determining is there no solution, one solution, or 2. Solve the triangle or solve both if there's 2. It does say round side lengths to the nearest tenth, round angles to the nearest degree. Okay, so for example 1, we have triangle RST. We are given angle R, we are given side R, and we are given side S. So if we compare what we have to what's up here, angle R is our given angle. So when we look at these formulas, this is like the angle A they're describing in these formulas. Side R is opposite angle R. So that's going to be like side A. And then the other side we're given is S, and that's going to be like the side B they're describing in the formulas. So if it helps to write that in so when you're comparing you know what to look at, that's fine. I'm just going to sketch roughly what this could look like. Looking at angle R, first of all, I see it's 95 degrees. So this angle is an obtuse angle. So if this is angle R, then side R would be here. I don't know exactly if I'm going to be able to create a triangle, so I'll draw it like that. That would be side R. This would be side S if I'm trying to match the diagrams that I'm given above. That's an angle marking, not a right angle marking. Okay, so looking at this, I see the angle I'm given is obtuse. So as I look at my chart, I'm looking over here. I then have to compare my 2 sides. So I'm comparing side R to side S. I see that side R is smaller than side S. So if that happens, because that would be like A is smaller than B, that means there's no possible triangle created, so this one is no solution. Okay, so I've seen students try to work through these without referring to that chart. They just see the problem, they start working through it. You'd be doing a lot of work for no reason if you started this one that way. There's no solution. You can determine that. You're done and move ahead. Okay? So the angle is obtuse, and then the side opposite is smaller than the other side, meaning there's no solution, no possible triangle could be created. This side R could not possibly reach this other side, is what that is saying. Any questions on that? Okay. So then example 2, we have triangle MNP. So we are given angle N, so that's going to be like the angle A in the formulas. Side N would be opposite that angle, so that's like the side A. Side P is the other side, that would be like side B. Okay, and I can see the angle I'm given is 32 degrees. It's acute. And I don't know exactly if I'm going to be able to, I'll draw this in if I can create a triangle, but I'm just going to draw it that way for now. This is angle N. This would be side N. This would be side P. Okay, so angle A is acute. And if I compare the 2 sides I'm given, I see that N is greater than P. That would be like A is greater than B. So if I look at my chart, the angle is acute. N is greater than P, meaning we have one possible solution. Only one triangle could be created here. Okay, so that means this would actually reach. And that means I have to solve the triangle. So I'm going to put one solution. And then I go ahead and solve it like we did on Friday using law of sines. Okay, are there any questions on how I determined that there was one solution? Because that's the newer part from Friday. We didn't have to determine that Friday. Okay, so then I'm going to finish labeling my triangle. I'm calling this side P, this opposite angle would be angle P. And my triangle is MNP, meaning my other angle must be M, and that other side must be little m. And then I'm going to fill in what I know. So N was 32 degrees, side N is 7, side P is 4. And like we talked about Friday, solving the triangle means you find everything that's missing. So in this case, we have to find angle M, angle P, and side M. And then just to review law of sines, and I'm going to write it in terms of M, N, and P. So law of sines would be sine of angle M over little m is equal to sine of angle N over little n is equal to sine of angle P over little p. What we didn't have to do Friday that we're going to have to do today is use law of sines to determine at least one angle. So we'll talk about how to do that since we were always given two angles with the ones we had Friday. So remember, for law of sines to work, first of all, we're using law of sines because this is not a right triangle. For law of sines to work, you need to have one full ratio, which we do. Because we have angle N and we have side N. So we have this full ratio here. So I'm going to set that ratio up. I have sine of 32 degrees over side N is 7. And that will equal. It's up to you what you want to find. Actually, it's not up to you what you want to find first. I'm going to go back on that. There's only one option for what we are able to find first. What do we have to find first? Measure of angle P, yes, because we don't know the measure of angle M or side M, so we would have nothing to fill in here, but I can fill in side P here and then find the measure of angle P. So I have sine of angle P over side P is 4. And then I can solve this for angle P. And remember, I usually don't type anything into my calculator until the end. So make sure on your calculators you are able to get these answers as well, because some things, depending on how you have to type it in, might be a little challenging. So remember, you can solve, this is a proportion, you can solve it by finding the cross products or setting the cross products equal to each other. So I would have, I'll write this as 7 times sine of P is equal to 4 times sine of 32 degrees. And if I'm trying to solve for angle P, I'm going to have to divide by 7. So sine of P is equal to 4 times sine of 32 degrees all over 7. And then if I have sine of P is equal to this, how would I find P? How do you find an angle? How do I get rid of the sine? Yes, the sine -1 inverse sine. I'd have to take inverse sine of both sides. So angle P is going to equal inverse sine of this whole thing And there are some different ways you can type this in your calculator. You can, if you have a calculator similar to mine where you can type in like an entire expression, you can just type this in, and I'll show that way. But here, make sure on your calculator you can get the right answer, and if you can't, then when you're working later, I can come around and help you figure out how to get the right answer on yours. So I would type in sine inverse, so second sine, and then I'm just going to type in 4 times sine of 32, and make sure I close the parentheses after the 32, and then divided by 7, and then I'm closing the parentheses for the entire inverse sine. And if I hit enter, I get 17.62651728. And that would be the angle for P. And we are rounding that to the nearest whole number. So right now, if you're not getting that decimal, just make a note that when you're working to ask me how to type into your calculator. Okay, so you should be getting about, if we round this to the nearest whole degree, that would be then 18. The 0.6 would round it up to 18 degrees. So angle P is 18 degrees. Okay, I still need to find angle M and side M. There's a way we can find one of those right now. Anybody know which one we can find and how?
The angle by subtracting 180 from 32 minus 18.
Yes, or, well, yes, take 180, yep, subtract 32, subtract 18. So all three angles add to 180. And so that would leave angle M to be 130. And then once you have angle M, now I can use law of sines to find side M. I am still going to use the ratio sine of n over n, that sine of 32 over 7, as the full ratio, even though I now know angle P because I rounded angle P. So I'm going to set sine of 32 degrees over 7 equal to sine of angle M is 130 over little m, which I need to solve for. We had done this on Friday, having to find a side length using law of sines. So find the cross product, set them equal to each other. So m times sine of 32 degrees equals 7 times sine of 130. And then I can divide by sine of 32 degrees. So 7 times sine of 130 divided by sine of 32. So round side lengths to the nearest tenth. So m should be approximately 10.1. Side m should be approximately 10.1. So there's one triangle possibly created from the given information, and this would be the remaining, or these would be the remaining measures. Any questions on that? Okay, couple of new things, having to determine how many triangles and then finding an angle measure using law of sines. So in the last example, you can probably guess if I did an example with no solution and an example with one, there must be an example with two solutions. So here we have triangle ABC, so it's already in terms of A and B. Angle A is 47, side A is 15, side B is 18. And I can see angle A is an acute angle. So I'm going to draw it this way for now. Okay, so I determined the angle is acute. I then need to compare my two side lengths. So I see that 15 is smaller than 18. My A is less than B. I will flip back if you're writing things down. When A is less than B, I then need to find the height to see if A is smaller than, equal to, or greater than the height to determine how many solutions I have. And again, you can find the height using this formula. If you forget that though, once you have your diagram, just say this is where the height would be. It drops down perpendicular to that bottom side. And when you have a right triangle, you now have H is the opposite angle A, B is the hypotenuse. So you have sine of A is equal to H over B. That's where that formula is coming from. So sine of angle A is 47 degrees is equal to, I'm trying to find H over B is 18. Meaning then my height, I would just multiply both sides here by 18. So my height is going to be 18 times sine of 47. So about 13.2. Okay, so I have A is less than B. Side A is 15, which is bigger than the height. So A is less than B, but it's also greater than H. And when that happens, that's this case here, that's when two triangles are possible. Okay, so there's two solutions to this one. And I will show you how to find both. Okay, any questions on how we determine that there's two solutions though? Okay, so solution one. Solution one, you're just going to find the solution. You're going to solve the triangle like you normally would. So what that triangle would look like is if I just continue drawing this side A down. So here's angle A, here's side A, here's side B. So this angle B, that's opposite side B, is going to be an acute angle. So you're just using law of sine just like we did for number 2. And that's why a lot of times when two solutions are possible, students always find one because they just go ahead and solve the triangle like they normally would and they get one solution. They don't think about the second one. So you have to know the second one exists to be able to find it. So we're just going to solve this like normal. Angle A is 47, side A is 15, side B is 18. And I'll write up here, so we have sine of A over A is equal to sine of B over B equals sine of C over C. So we have to use our full ratio, which is going to be sine of A over A. And since we're given side B, we're going to have to find angle B first. So let me write down what we're trying to find here. I should finish labeling this too. This would be angle C. This would be side C. So I'm looking for angle B, angle C, and then side C. So I would have sine of angle A is 47 degrees over side A is 15 equals sine of B over side B is 18. I'm going to solve for angle B. So find the cross product, set them equal. So 15 times sine of b is equal to 18 times sine of 47. Solving for angle B, I'd have to divide by 15. And then I'm going to write it this way right away. I can see I'm going to have sine of B left, and I know from the example we just did, I'm then going to have to take the inverse sine of this entire side. So angle B is going to be inverse sine of 18 times sine of 47 degrees divided by 15. So let me calculate that. So second sine for inverse sine, 18 times sine of 47, close the parentheses, divided by 15, close the parentheses, enter. And again, rounding to the nearest whole number, so it's 61.3571157, so about 61 degrees. The 3 would keep the 61, or rounding down if you think of it that way. So angle B is 61. Okay, then we can find angle C. Like we did in the previous example, we have two angles, subtract them both from 180. So 180 minus 47 minus 61 is 72. So angle C is 72 degrees. And then since I have angle C, I can use law of sines to find side C. And I'm still going to use the sine of A over A. So sine of 47 degrees over side A is 15 is equal to sine of angle C is 72 degrees over side C is what I'm trying to find. Set the cross products equal to each other. So C times sine of 47 degrees is equal to 15 times sine of 72. Solve for C, divide both sides by sine of 47. So 15 times sine of 72 divided by sine of 47. Rounding to the nearest tenth is about 19.5 for side C. Okay, so that's solution 1 with angle B being an acute angle. Okay, solved just like we did the previous example. So then here's how you get solution 2. And I'm going to try to draw what this triangle would look like. That diagram was kind of on the front. So it would mean this side A is kind of rotated over this way. So it's a very skinny triangle. Side C is going to be very, very short. So it's kind of like this. So this is still A, that's still 47 degrees. Side A is still 15, side B is still 18. But now you can see angle B is going to be an obtuse angle. Angle C is going to be a very, very small acute angle, and then side C is also very, very short. But we're still finding the same information. We're still finding angle B, angle C, and then side C. Cora. So it's shown better here when you have an acute angle A, and then side A is shorter than side B, but side A is longer than the height or the altitude. So, because you're not given this side length, so you don't know how long or short it is. So it could be longer, and then your side A could be here, and that angle B is acute, or it could be rotated this way, so this could be your side A, and your side C could be very short, and then this would be your angle B. So pink was the first triangle we just found, and then what I put in blue would be the second smaller triangle that you could have. Does that make sense? Okay, I know it's kind of hard to picture, but that's where they're getting the two triangles from. Okay, here's how you find angle B. You still find angle B first, because if you think about it, if you just do what we did for solution 1, you're going to get the same exact thing. So the best way I know to explain this is if you think about your coordinate plane, so you have quadrant 1 and quadrant 2. We found in the first problem that angle B was 61 degrees. If you remember back to, it was in 12.3, remember that all trig functions are positive in quadrant 1. Sine, which is the trig function we're using in law of sine, sine is also positive in quadrant 2. So say this is approximately where 61 degrees would be. If I drew an obtuse angle, say over here, so that angle goes all the way this way, and say the reference angle was 61, this acute angle and this obtuse angle are going to have the same exact sine value. So if I found sine of 61 and then sine of this obtuse angle, those values would be the same because sine is positive in both. So how you find angle B is you simply take 180 and you subtract the acute angle you got for solution 1. So if I take, and I'm taking 180 because that's this semicircle halfway around here. So if I take 180 and subtract 61, that's 119. That is the other possible measure for angle B if it was obtuse. And again, the reason why is 61 is a reference angle for 119. So here, if I prove this to you, sine of 61 degrees is about 0.875. Now let me find sine of 119. It's the exact same thing. So that is why there's two triangles possible, because sine of both of those angles is the same measure. So then that makes finding angle B easy. You just take 180 and subtract this acute angle you got here. Finding angle C, you then take 180 and subtract your angle A and your angle B. So angle C is going to be very, very small. So 180 minus 47 minus 119. So angle C is only 14 degrees in that triangle. And then you'd have to use law of sines to find side C with your new angle C. Okay, so I'm still going to put sine of A over A. So sine of 47 degrees over side A is 15 equals sine of angle C is now 14 degrees over side C. And then find what side C would be in this triangle. Set the cross products equal. So C times sine of 47 degrees equals 15 times sine of 14 degrees. Divide by sine of 47. So 15 times sine of 14 divided by sine of 47. So side C to the nearest tenth, that 9 is going to round up, so it'd be about 5.0. So it's very short compared to the other two sides. Okay, so like I said, with this type of question, you're usually able to get one solution. If you don't think about the second one, to find the second one, you have to first know it even exists. So refer to that chart. I will pass out the practice